Think of all the luck you got. Know that it's not for naught. You were beaming once before, but it's not like that anymore. Count all the moods you've known. No, they're not stuck in stone. You were patient once before, but it's not like that.
Hello, I'm Amy Dominguez, and I will be your narrator throughout this project. Our experiment is how yeast cells react to different microplastics. Please sit back and follow along. We decided to investigate this particular experiment because we wanted to analyze the effect of microplastics on yeast. It is widely known that microplastics are harmful to the environment in more ways than one. Not only do they affect marine life, but they can potentially harm terrestrial organisms as well. We discovered that both PET and BPA were damaging to yeast cells after conducting study on the subject. Therefore, we wondered if exposing SRCA to PET and BPA would result in a decrease in cell mass. Since yeast is a fungi and fungi decomposes dead organisms to survive, we thought about how far the yeast could decompose a plastic. We came to our hypothesis, which is if yeast is capable of digesting microplastics, there would be an increase in yeast cell mass. We had a lot of issues with the YPD broth solution early in our experiment. At first, we mistook it for agar, which after some time solidifies and is placed in petri dishes. When we realized it was broth, we remixed the solution, but air exposure caused it to become contaminated. To prevent contamination, we determined it would be best to prepare the broth, autoclave it, and pour it into the conical tubes all at once. As soon as we got all of our tubes prepared, we inoculated them with each quantity of PET and the yeast, SRCA. 30 tubes in all, including the control and our treatments, were used in the experiment. The yeast had settled to the bottom of each tube after each sample had been incubated for 24 hours at 30 degrees Celsius, and we used pipettes to resuspend them. We sucked in a tiny amount of the liquid, YPD broth, and then let it flow over the yeast, causing it to expand and stir. This procedure was repeated multiple times until the bottom of the container was clear of all yeast. The absorbance of each tube was determined using a spectrophotometer to extract a small amount of fluid from the sample from which we were measuring the absorbance. We used pipettes. We labeled the tubes to keep track of the process. We then placed the cuvette into a spectrophotometer after filling it with the fluid until it was 3/4 full. We had to wait a minute after hitting the start button for it to stabilize and provide an accurate readout. We changed the wavelengths to 650 nm after 1 minute. We would note that samples and absorbance and on the spectrophotometer image of the electromagnetic spectrum in order to monitor everything. We had calculated the molarity of each tube because we intended to utilize Beer's law on the spectrophotometer, but we were unable to do so because neither the PET nor the yeast had combined. Our mentors assisted us in entering the absorbance of about 30 samples as our first data set and calculating the t-value after we had categorized it and created a chart with it. As we got ready for trial 2, we decided to try a different microplastic, BPA. The process is similar to that of trial 1, but more efficient. We made the full recipe of YPD broth solution, 50 grams of powder and 1,000 milliliters of water, and autoclaved it. The inoculation and pouring both happened on the same day. We decided it would be best to increase the amount of microplastic that was going to be added into each conical tube, increasing the BPA by 50 milligrams by each round. Since our incubator wasn't working at the time, we left our samples under the fume hood. The next day, we tested for absorption using the spectrophotometer at 9 a.m. and did so again at 12:30 p.m. We created our data sheet, which included our average, standard deviation, t-test, and variance. To ensure the accuracy of our findings, we intended to test for absorption again the following day after keeping our samples in the incubator at 30 degrees Celsius for 24 hours.